Hello, this is Dan Ludwigson again, coming from the new Learning Commons. I'm enjoying a little cappuccino this morning, and I thought I'd present a little bit about circuits as we get into our lab with light bulbs. So in this circuit simulator, you can see where I'm working. It's the PHET, P-H-E-T group out of Colorado. They have put together this little cartoon version of a circuit simulator, and you can just do an online search for PHET, and then circuit DC, that'll bring it up, I'm sure. So I've put in here you can see a battery, you can see a selection of light bulbs I've arranged in some crazy kind of configuration, and then a switch at the bottom. And in this cartoon, we've got little electrons being shown here. According to this, we could take a look at regular current and see how that flows. Down here in this switch, if we close the switch, the current starts to flow. And the light bulbs light up. Now these three light bulbs all have different resistances, so we don't, they're all three different. If we wanted to take a look at electron flow, you notice that definitely those are flowing opposite the way we define conventional current to flow. So we've got these little electrons flowing, or we've got this current flowing, depends on how you like to look at things, and the light bulbs light up. So the brightness is proportional to power in these light bulbs, which is a product of both voltage and current, right? So I've got my voltmeter here, and I've got a current meter. We'll be using a multimeter to do both jobs, but in this simulation, we select those tools from here. So I've just got these ready to go. And if I wanted to measure something like voltage, we always say voltage across and current through. So the voltage across one of these light bulbs, well, let me take a probe and place it on one side of the light bulb, and then take the other probe, the common, or the black one is usually the ground, and I get a voltage of 2.54 volts across that guy, and that's just for the sake of reference, that would be in comparison to this 9-volt battery. All right, so you get the idea. Measuring voltage, you put those two leads across a certain element and measure voltage across. It's the potential difference between those 2 points, the difference in electric potential. Okay, just for the sake of argument, you notice what happens if I put this red probe, the high side, on the low side, low potential side of that first light bulb, I get a negative voltage. So we're dropping down in voltage as we go from this side to that side. And that's according to the direction of current flow. Current likes to flow downhill in terms of potential. So that seems to all fit together reasonably well. All right, now if you wanted to measure current through one of these wires, you would need to actually break the circuit. So let me do that here. I'm going to grab this guy and snip that, and then I'm going to insert my current probe. Connects there, and then I connect it up there. All right, so now it's flowing again, and I've got 0.36 amps flowing into the negative terminal of the battery. You could compare that, for example, to the current that's flowing in this leg or this leg. This is a parallel combination. Just as a reminder, those voltages across a parallel combination should be the same for both of those two light bulbs, but the currents will be different because they are different resistances. All right, so the last thing I wanted to mention here is a little caveat, a little warning, little safety element. So let me take this guy off, and let's say that we, for whatever reason, we're messing up and we put a voltage meter inside the current, inside the circuit. So it acts like a current meter, except it's a voltage meter. In this simulation, it doesn't blow up. But in our real life laboratory, it will blow a fuse in the current, or in the meter. We have these fuses to protect the circuitry of the multimeter, because if you connect a voltmeter which is supposed to have super high resistance and not allow current to flow, in a circuit as an ammeter should be connected. That is in series, so it absorbs the flow of the current. We want to protect the voltmeter, so we put these. The manufacturers put these fuses in a voltmeter, in the multimeter in the back. One lab section I remember, we blew probably 9 fuses as different groups made the same mistake over and over again. It was ridiculous. So, big warning, it's embarrassing for the instructor when this happens. You don't want to blow a fuse on your voltmeter, so don't connect it like an ammeter. All right, that's how you work with these voltmeters and ammeters to measure voltage and current. You have to break the circuit to insert the current, and you have to measure across to measure voltage.